Alright, here we go. We're talking about matter today in our books. If you're following along, it is chapter 3, and we're specifically going with 3.1 and 3.2. So matter. You should have your notes, you should be following along, and you should be writing down a whole bunch of stuff. So let's hope you're doing that. Here we go. Chemistry is the central science that studies matter and the changes that it goes through. Alright, and that's what this class is all about, chemistry. So, you see a lovely snowman there. He's in the solid form of matter, right? Melting away, that's a change in matter, something we'll look at as we go throughout the year. We got some lovely fireworks going off there, right? Fireworks, definitely chemistry involved. We'll talk a little bit more about that in the months to come. So here we go, matter. So, what exactly is matter? Well, matter is anything that has mass and volume. So anything that has mass and volume we consider to be matter. Alright, well, we just used the word mass there, so what is mass? Mass is the amount of matter something has. Alright? Mass is the amount of matter something has, or the amount of matter that's in an object. And then we use this word volume up there, and volume is the amount of space an object takes up. So mass and matter and volume, they shouldn't be new words to you. Hopefully they're a review, but if they are new words to you, make sure you get those down. Alright, so when we talk about matter, we like to classify matter. This is what scientists do. They classify matter, and they do it based on their properties. At the bottom of the screen here, you can see we got these three lovely things here. Alright, we got some peas here, or some beans. Alright, next to it, one of my personal favorites, asparagus. Put a little oil on there, a little salt and pepper, grill them up. I'm telling you, so good. Alright, and then we got some lettuce here. So, how do we classify all of these? So, what are some common properties? This is how we classify stuff. So, I would say that they're all green. And specifically, even more, they're all vegetables, right? So, this is what we do. We're going to classify a lot of things in chemistry. We'll classify stuff as solids or liquids or gases. We'll classify stuff as metals and non-metals. It's all kinds of stuff we're going to do in here. Alright, so classifying matter is what chemistry, or chemists do, alright, to make sense of the world. So classifying matter is what chemists do to make sense of the world. Alright? And we base these on common properties, as we just talked about, and properties describe traits of matter. They describe the traits of matter. We talked about it just a second ago with our vegetables. They were green. All right, that was a trait of the matter that we were describing there, the properties. All right, there are two types of properties. Maybe you already know this, maybe you don't. If you do, go ahead and say it out loud right now. All right, did you actually say it out loud? They are physical and chemical properties, physical and chemical properties. Let's talk about some of those. So, physical properties can be observed with the senses. We can smell them, we can taste them, we can touch them, we can see them, we can hear them. So anything with the senses, alright, can be observed as a physical property. They can be measured, okay? So we can get out a tape measure or a ruler, alright? We can get out a ruler. This is my beautiful ruler here. I know you're loving it. Oh. For some reason my little pen thing is not wanting to write here. Okay, it's going a little crazy on me. Give me 1 second. Alright, so here we go. So, rulers, right? We can measure the lengths of things, like this line here. We can use a graduated cylinder or stuff like that. So, properties that can be measured. Here's some examples: density, color, odor, taste, hardness, boiling and melting, freezing points, conductivity, etc. There's a whole bunch of words there that you don't have to know the definition of all these right away. We're going to go over a lot of these, but these are some examples, okay? All of these physical properties we can observe, and it doesn't change what the object is. Alright. So, chemical properties describe the ability of two substances to react. A couple things you might see here. You see a trash can with those blinking eyes. On that trash can you see maybe the brown areas. That's rust. Alright? The metal in the trash can has reacted with the oxygen to form rust. Metal, oxygen, two new things coming together, making something new, which is rust. Okay, two things coming together make something new. We have a match there. We know what matches are used for. You strike them to burn. Alright? What is that match going to react with? Well, oxo with oxygen in the air. Okay? And the last one there, well, chemical properties also describe what things do not react with. On the bottom there, you might see a gold ring, hopefully. Alright? One of the good things about gold is it does not rust. It does not react with oxygen. So, good thing to have gold rings. They last a long time. Alright. Changes in matter, alright, often occur, and there are two types of changes. And this should look familiar. The two types of changes are physical and chemical. So we have physical changes, we have chemical changes. Let's talk about those. Physical changes. Changes what the substance looks like, but does not change the substance itself. Okay? So all of a sudden it looks different, but it doesn't change the substance itself. Oh, here we go. We have a little picture that shows up. Those are Coke cans being crushed. Alright? Once it crushes it, still a Coke can, right? Doesn't change what it is. Alright? We got another one here. Paper cutting. If you take some scissors and cut some paper, doesn't change what it is. It's still paper. So what you ask yourself when you come across something like this is, do I still have what I started with, or can I get back what I started with? Okay? So if you answer yes to any of these, you know you have a physical change. Alright, let's watch a physical change. Let's go back to my arrow here. Oops. Alright, this is, if you've seen Mythbusters before, this is a car, they did a little experiment. This car was dropped from over 100 feet and boom! Hits the ground and breaks into all kinds of pieces. Now, the car breaks into all kinds of pieces, but this is just a physical change, okay? I guess if you wanted to, you can hammer and put back all those pieces if you wanted to and make the car back. That would probably take a while. Alright, other examples of some physical changes. Cutting wood, alright, breaking glass, boiling water, freezing water, and dissolving sugar into water, which is called solubility. We'll get to that one later. Now, let's look at a couple of these. The hardest ones when it comes to physical changes are usually the changes in states. Right? When we boil water, okay, it goes from a liquid to a gas, but it's still water. Right? And then, one that's really hard for students sometimes is this dissolving of things in water, such as sugar. Right? However, you know, when you put sugar in the water, you can't see it. When you taste it, you still taste the sugar and you still taste the water. Same thing with salt. Put salt in the water, dissolves. That's still a physical change. We're going to talk more about that in class. Alright, okay, chemical changes. Chemical changes, a new chemical is formed once a substance reacts with another substance to produce a new one. Alright? And the substances have different properties. It looks different and reacts differently. Okay? So chemical changes. I'm going to go on, but again, pause here if you need to write something down or go back over it. So I'm going to give you some examples. Alright. Chemical change. We're going to look at this in just a second. When sodium and chlorine react together, they make sodium chloride. Salt or table salt. Okay? So, sodium is actually a metal. It's actually a really soft metal, really reactive. Chlorine's a gas. Alright, when you put them both together, you can see on the very right there that all of a sudden, way over here, right? Oops. Forgot it. Alright, way over here, right? You have something that looks totally different than the other ones, and they definitely react differently. Now I'm going to show you a fun film of sodium chloride being created. Don't try this at home. Alright, what we have here, this guy's named Theo Gray. He is actually, this is chlorine being pumped into here with sodium, and you have popcorn over top of it. So he's actually salting his popcorn in a really dangerous way. Alright, and what you saw there was when it busted open is the popcorn actually fell down into it, causing even a more violent reaction. So that was making sodium chloride the hard way. There's easier ways to make it. Alright, some other examples of chemical reactions. Something that explodes. Flammability or combustion. Okay, that guy's got a firecracker going there. Rotting or decombustion. You ever smelled smelly fish or cheese there? Yeah, you got a chemical reaction going on there. Digestion, when you eat something, chemical reactions happen in our stomachs. Alright, and neutralization, speaking of stomachs, when you use Pepto-Bismol, yeah, you neutralize your stomach, make it feel better. Alright. Alright, some words that come up when we give you clues. So, if I'm reading through a problem, alright, and I ask you, well, is this a chemical or physical change? Here's some ideas or some clues that say it's chemical change. If I use the word reacts with, produces, forms, decomposes, neutralizes, synthesizes, combustion, or flammability. Alright, there are more, but those are some big ones. When you hear those words come up, you know a chemical change is going on. Alright, evidence that a chemical change has occurred. So let's say you're doing something in lab. Alright, and you're like, man, I wonder if this is a chemical change or not. Well, some things happen, such as gas bubbles can form. Let's say you put two liquids together and all of a sudden you see a whole bunch of bubbles forming. Probably a chemical change going on. Color change, okay? This can be physical, so you have to be careful, but color change can occur. Precipitate forming, ooh, big word there. What this means is a solid form, so we're going to see a video of that in just a second. And then temperature or energy change. All of a sudden you see smoke or feel a lot of heat, or it can do something else. It can actually get really cold too. Any temperature change usually is a good idea. That's a chemical change. Alright, and the release of an odor. All of a sudden you smell something, probably a chemical change going on. Alright, so here's a little video we're going to watch. This is potassium iodide and lead nitrate. You can see they're both clear liquids. All of a sudden we're going to pour one into the other. And whoa, look what just happened there. Alright, two things happened here. One, you got a color change. The next one is hard to see here, but it's really thick. You actually have a solid form as well here. Okay, so you have a change in state. So when a solid forms a precipitate from two liquids, it's a chemical change. Alright, so let's look at some. We have copper before and after. This is what happens when copper gets oxygen to it. It turns green. And if you did not know this, the Statue of Liberty is green. Why is it green? Well, Statue of Liberty is made of copper, and it's actually reacted to form this copper oxide that is green in color. We have silver here, and silver tarnishes, also reacting with oxygen to form it's not so nice and silvery color anymore. It's kind of a brown, dull-ish color. We have some iron here, and this iron rust also reacting with oxygen. Oxygen does a lot of things to chemicals. It reacts with a lot of things, so we'll talk about that a lot. And we'll quiz you here. Is this a physical or chemical change? Is this a physical or chemical change? We'll talk about it in class. See y'all later.